After building my first convolutional neural network, I wanted to continue researching deeper architectures and machine vision. So I started searching the internet. I read a couple of papers and watched tons and tons of videos until I finally found the project I wanted to develop. I present to you UNET. UNET is a convolutional architecture created by Olaf Runeberger, Philip Fisher and Thomas Brooks in 2015. Time has passed since then, but UNET architecture was one of the greatest steps in computer vision. Initially, this model was developed for semantic segmentation, which consists of differentiating and classifying different regions of an image. Today, this architecture has inspired several other models such as GAN, where it is used to generate completely new images that have never existed. If you want to learn more about UNET, I leave you its paper in the description, and also a link to a video by Alan in person. Check his channel because he has very interesting videos on neural networks and tutorials on how to program them in Python. But for this project, I wanted to focus on the original application of UNET, the semantic segmentation. To develop my model, I've chosen the Carvana Kaggle competition, where the objective is to train a neural network capable of receiving the image of a car and separating the vehicle from the background. In order not to have to download the whole image dataset and not saturate my computer memory, I will be working on Kaggle notebooks. I hope that despite some bugs that I have already seen, it will work well. And if you want to check the code, I will also leave the link in the description. But let's stop chatting and get programming. Like last time, I'll start by importing the libraries and then I will load the data. Since the files are encoded in zip format, I need to extract them using the zip file library. Then I will list all the image names and print them out to see what they look like. Unfortunately, the image and its mask are unordered, so I need to find all matching pairs first. After creating the data array, I split the set into 80% training and 20% validation. Next, I created the image preprocessing and data augmentation functions, keeping in mind that now I need to apply the same transformations to both images, input image and the output mask. The functions are very similar to the Ape image classifier project, but in this case I won't modify the contrast and brightness of the image, because it is not necessary and can worsen the training. Finally, I define the load image function and create the datasets. After building the architecture and trying to train the model, I got some weird errors that I didn't quite understand. I started looking for them on the internet, but I didn't find any good answers. Also, I had already received other warnings and errors that I hadn't seen before, so finally I decided to switch to Jupyter Notebook. I had to download the images, But in the end it weren't very heavy because I only needed the train and the train mask zip. I opened a new notebook and just copied the latest code. This way, without using the zip file library, the images were already paired, so I didn't have to do anything else. Now, let's go with the architecture. If we take a look at the UNET paper, we see that we can divide the model into three different parts: the downsampling path, the bottleneck, and the upsampling path. The downsampling and upsampling paths are symmetrical. That means we must get the same output dimension as the input ones. Between each block in the downsampling path, there is a skip connection that links the output of the blocks to their corresponding upsampling block. In the code, I'm going to start by programming the downsampling and upsampling blocks. For downsampling, you only need to do two consecutive 3x3 convolutions with ReLU activation, stride 1, and padding same. At the end, a 2x2 max pooling layer is added, which will decrease the size of the image by 2. Next, on the way up, we need to first apply a 3x3 convolution transpose with a stride 2 and equal padding, which will increase the image dimension by 2. And then, two convolutions layers are applied just like on the way down. For the model, I will use another class called model0. To initialize the class, I will define the variable self.path that will contain the number of filters for the downsampling and the upsampling paths. Then I define the middle part of the bottleneck, which will consist in two consecutive convolutional layers of 1024 filters. And finally, I define the last layer of the model that will be a 1x1 convolution layer of only one filter. I use only one filter because the training mask, that is the output, has only one channel because we are looking for binary segmentation. Going up to the call function, I've created an empty list called skips, and each iteration of the loop I'm going to be appending to this list the second output of x, and x will only be the first output. Then I enable the bottleneck section, using again a for loop. And finally, I create the upsampling path. In this case, I will also have to modify the CNNU block, because the skip connection will be concatenated after the transpose convolution layer. The explanation for this is that since we cannot concatenate two matrices with different shapes, we must resize one of them, the X or the skip. But which one is the correct one? The correct answer is the skip connection, because it is only affected by downsampling the image, keeping the original image sizes at each step of the downsampling. On the other hand, the shape of X may change depending on the sizes of the original image, since odd dimensions cannot be halved exactly, and thus the dimensions between path down and path up will be different. Now we can compile the model using Adam Optimizer and categorical cross entropy as loss function. If I call the summary method, we can see how the input dimensions change in every step of the model, making sure that the input and output dimensions are exactly the same. Apparently, the model is built correctly. However, if I try to train it, I get the same errors as before, so I haven't figured anything out since. The first error is this. I think it could be because the Keras subclasses output two different values instead of just one, since in a neural network a neuron can only output one value. However, if I comment out those lines and try to train the model again, the console starts loading this thing. It is very slow and the computer starts to crash when I run it. I'm guessing it's due to the shuffle feature on the dataset, but it didn't happen on the monkey image classifier, so I don't know why that is. So this has been everything for this video. It's a pity that I can't train the model and see the results, but I'll try to fix it for the next video and I will show you. If anyone has any advice or suggestions, I'll be happy to read it in the comments. I hope you liked the video. If that, remember to give a like, leave a comment and subscribe to the channel so you don't miss any upcoming content. See you in the next video.